On the topic of partial fractions, we have some important strategies. In the very first case, so let us write it as case 1. Suppose you have a rational expression. Like what? Like R of x divided by Q of x. Suppose your denominator and the denominator, which is Q of x, can be written as Q of x, the product of distinct linear factors. The product of distinct linear factors. What do we mean by that? So suppose Q of x can be written as A1 x plus B1 times A2x plus B2 times the rest of the terms, A sub k x plus B sub k. So this is your very first case. If the denominator can be written this way, then for the rational expression, you can divide up the rational expression into partial fractions this way. Then Rx divided by Qx can be written as, so Rx Qx can be written as, well, A sub 1, which is just a number, divided by A sub 1x plus B1 plus the second fraction, which is A sub 2 divided by A sub 2x plus B2 plus the rest of the terms, A sub k divided by A sub kx plus B sub k. Then our goal is to identify what is A sub 1, A sub 2, A sub k, and so on. Then our goal or our job is to find the numerical values for A sub 1, A sub 2, A sub 3, and A sub k. This is our very first goal. Let us go over one simple example. In this example, I ask you separate x plus 5 divided by x squared plus x minus 2 into partial fractions. So this is our very first case. Why is that? Since the denominator. Can be written as, so here you have x squared minus x plus x minus 2, which can be written as, so we're looking for two numbers that their multiplication is equal to -2 and their sum is equal to +1. Those values are x minus 1 times x plus 2. So this is your denominator. Okay. X plus 5 divided by x squared plus x minus 2 can be written as two fractions. The very first fraction has an unknown on its numerator, which is a sub 1, and on denominator you have x minus 1, plus the second fraction that has an unknown number on its numerator divided by x plus 2. So how do we find a1 and a2? To find a1 and a2, we need to take common denominator. To take common denominator. So take a look. On this side, it is equal to a sub 1 times x plus 2 plus a sub 2 times x minus 1. Everything is divided by the multiplication of x minus 1 and x plus 2. But pay attention here. On the left-hand side, the denominator is x squared plus x minus 2. On the right-hand side, the denominator is the same. It's just a multiplication. So you only need to take the numerators and set them equal to each other. X plus 5 is equal to a sub 1, x plus 2 plus a sub 2, x minus 1, and identify the values for a1 and a2. So let us begin. Set the numerators equal to each other. So on the left-hand side, I have a linear expression x plus 5, or more specifically, 1 times x plus 5. On the right-hand side, what do I have? I have a1 times x plus 2 plus a sub 2 times x minus 1. In setting these two equal to each other, you can do a little bit of trick, or you can use a general approach. Both of them are absolutely fine. In doing the trick, let me write it down here for you. For shortcut, for that sake, not the trick, it's a shortcut. You can set x equals to -2 so it becomes -2 plus 5. And on the right-hand side, you have a sub 1 times -2 plus 2 plus a sub 2 times -2 minus 1. Okay, so what happens here? Well, this quantity is just 0. On the left-hand side, we end up with 3. On the right-hand side, you have a sub 2 times -3. So if you just divide by -3, a sub 2 is nothing but -1. So one by one, get rid of some of these linear expressions and calculate the value for a1 and a2. So to find a sub 2, set x equals to 1 and see what happens here. 1 plus 5 is equal to a sub 1 times 1 plus 2 plus a sub 2 times 1 minus 1. Well, this guy is equal to just 0. So what does it tell me? It tells me, hey, 6 is equal to a1 times 3 a1 times 3. So what is a1 then? a1, if you divide both sides by 3, a1 is 2. Hey, we found the values for a1 and a2. a1 is 2 and a2 is -1. So we can separate this fraction, which was x plus 5. So our rational expression can be written as x plus 5 over x squared plus x minus 2 as a1, which is 2, divided by x minus 1 plus a2, which is -1, divided by x plus 2. So that's how we separate this fraction into two partial fractions.